Welcome back. Your second lesson for solving polynomials. We are going to, your second lesson for inequalities and rationals. We are going to solve polynomial inequalities. And that's quite simply our learning goal, solve polynomial inequalities. We're going to get right to an example. So last lesson we did linear inequalities. The degree on x was just 1. Here though, you can see this is in factored form. This would be a polynomial if you distributed and FOILed and collected like terms. You got 1, 2, 3 x's. This would be a cubic. This would have a degree of 3. So this is a polynomial. What we are looking for is still the same. We just have to go about it in a little bit of a different way. So before I get into the solution, I was going to show you again. I try to give you a graphic, and like I said, normally we'd be able to have some fun with this using some graphing software, but for now I'm just going to have to give you a picture and show you. So there's a picture, a graphic of our solution, and you can see that blue graph. That is our polynomial, that's our cubic. And we learned how to graph those in the last unit, or hopefully you did when you were graphing polynomials. And then those red sections, those are the solutions. If you take a look at the equation on the left where the red is, that's our inequality we're looking to solve, and it wants to know when it's greater than 0. What does that really mean? Well, that really means when is it above the x-axis? In other words, when is my function positive? When is my function negative if it was less than? So you can see that first red section, my blue graph is above the x-axis between -3 and 1. That means it's above the x-axis, it's positive, that is a solution. Then between 1 and 4, it dips down below the x-axis. So it's negative, so that's not a solution. And then at 4, it crosses the x-axis and it goes on to infinity forever above the x-axis. It's positive. So that's a visual of what we're going to try to do algebraically. Now this one's an easy one to graph. You could graph this and then based off of the graph, give me the solutions. That is a possibility, but for those that don't like graphing, or sometimes like this one's easy because I've already factored it for you. Other times it might be a bit more difficult to know what the graph looks like. So let's solve this kind of algebraically. And we're basically, at the end of the day, for all of these, we're going to be making a modified x-axis anyways. The first thing that you always want to keep in the back of your mind, what matters if you are positive or negative? So if we think back to that picture, what mattered? It mattered where I cross the x-axis, because once I cross the x-axis, I'm either positive or I'm negative. Where do you cross the x-axis? You cross at your zeros or roots or solutions. So you need the zeros. So that's where we're going to start here. You need the zeros. How do you get the zeros? It's got to be factored form. Like I said, this one was easy to start because I already gave it to you in factored form. Step number 1 would be to factor this. It's already factored. Step number 2, state your zeros. X equals -3, 1, and 4. Now to figure out your intervals, you're basically going to make a modified number line, a modified x-axis, if you will. So we're going to draw this line. And I'm going to put some numbers on here. And what you want to put on there are your zeros. So -3, 1, and 4. And we want to figure out what happens. I'm going to put a dashed line up and down here. We want to figure out what happens in between all of those intervals. And how you do that is you just you pick a value in each interval and you test it. So we want to figure out what happens here. So left of -3. So pick a number less than -3. It doesn't matter what you pick. I'm going to pick -4. So f of -4. Then you take that number and you just plug it into your function. Now we don't even care about the numbers. All we care about is the sign, meaning is it positive or negative. So our first factor of our function, x plus 3. If I put -4, -4 plus 3 is -1, negative. I'm just going to write a negative there with a circle around it. Now put it in, negative to the next one, -4 minus 1. That's -5. Again, I don't care what the number is. I just care about the sign of it, which is negative. The third factor, -4 minus 4, -8, that's negative. When you multiply 3 negatives, what is your net result? Well, your net result is negative. Now, to determine what is a solution, you got to look at this. That is greater than 0, which in other words means when is it above the x-axis, which when is your function positive? I got a negative here. This is not a solution. Okay, now we want to figure out what happens between here and here, between -3 and 1. Pick a number. You can pick anything you want between those two. 0 is the easiest, so I'll pick 0, f of 0, 0 plus 3, positive 0 minus 1, negative 0 minus 4, negative. When you multiply those, a positive times a negative, you end up with a positive. That is a solution. So all I'm going to do is just write a little check mark here so I know that's a solution, and then we'll tie it up after. Now I want to figure out what happens between here and here. Pick a number between 1 and 4. Let's say 2. 2 plus 3, positive 2 minus 1, positive 2 minus 4, negative, positive times a negative. That is a negative. We don't want that. We want positives, not a solution. Now I want to figure out what happens bigger than 4. Pick 5. You could pick 10. You could pick 100. Doesn't matter. 5 plus 3, positive 5 minus 1, positive 5 minus 4, positive, net result positive. That is a solution. So to actually give our answer to solve this polynomial inequality, therefore, so we have a solution -3 to 1. So -3 is less than x is less than 1. We're not going to put equal to's because it doesn't have an equal to in the question. And x is greater than 4. That was our 2 check marks, the 2 solutions we were looking for. And remember, if you don't like that notation, you could write between -3 and 1 like this, right? With circular brackets. And from 4 to infinity, also with circular brackets, because they do not include the point. And there is our solutions. Now again, I talked about this. This is basically just a modified x-axis. So if you were to make your graph, right, you have zeros here, here, and here. This is a cubic, positive leading coefficient, right? So odd degree, where are the end behaviors? Here and here. And that's basically the picture that the graphic I popped up for you, what it look like. And that graph matches our solution set, right? Where we had check marks, it's above the x-axis. Where we don't have solutions, it's below the x-axis. It's negative. In terms of work you need to show, I need to see this. So everything that you see in front of you, I need to see. Again, you have a lot of resources at your fingertips. You have to prove to me beyond a shadow of a doubt that you know what you're doing, you yourself. So If you're someone that thinks you might prefer to do the graph, that's fine. You can make the graph, but I still want to see what numbers you tested and what the end result was. So just like you see for me, -4, 0, 2, and 5, if you make the graph, I want to see on the graph what numbers you picked and how you know they're positive or negative. To play it safe, again, since we're not in the classroom and I can't really monitor or I don't know you that well, stick to what you see in front of you. And then there's no doubt that you can get full marks when you're showing me the solution to these. B, solve. Step number 1. I need to find the zeros, which means I need to have it in factored form. A was easy. It was completely factored for you. B, we got to factor it. How do I factor that? Well, you just did a whole unit basically on factoring polynomials. You got to do factor theorem. So you want to test factors of 12. So on your own, you would do this, test plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, so on. I'm pretty sure f of 1 works. So f of 1 equals 0. Therefore, x minus 1 is a factor. Once you're there, synthetic division, write your coefficients, 2, 3, -17, and 12. Bring that down. 2, 1 times 2 is 2. We're forever adding. Add, multiply, add, multiply. You know you did it right because you got a 0 remainder. So this equals 2x squared plus 5x minus 12. And that's a trinomial. It's not a simple trinomial, so you could do decomposition or you could do box method. I'm assuming everyone by now knows how to factor. So I'm not going to go over how to get the answer, but if you need a quick review, let me know. 2x minus 3, x plus 4. Don't forget we had the x minus 1 from above, and we want to know when that is greater than 0. So we need our zeros. X equals, from our first, 3 over 2, -4, and 1. Put those on a number line, or modified x-axis if you will. -4, we'll say, is roughly there. Then 1. Then 3 over 2, which is just 1.5. I like to draw those boundary lines just to keep things separated. It's a good idea, but you don't have to. Pick a number less than -4, -5, put it into, now you could put it into your entire equation up top if you really wanted to. If you do that, make sure you make a note of it for me. If you do that, that's just calculator work. It's easier to me just to put -5 into each of our factors, which would be 3 negatives. And that overall result is a negative. I want greater than 0, meaning I want positive numbers, not a solution. Pick a number between -4 and 1. 0 would be the easiest. That would be negative, positive, negative. Just using my factors down below. Multiply those. Overall positive. That is a solution. Now, if fractions aren't your thing, right? This is between 1 and 3 over 2, which is 1.5. So you could pick, I don't know, whatever you want, 1.2, let's say. And when you do that, you get negative, positive, positive. That net result is negative, and that is not a solution. Pick a number bigger than 3 over 2. Remember, that's 1.5. You could pick f of 2. They're all going to be positive. Net result positive. That's a solution. Therefore, now since it was just a greater than symbol, not greater than or equal to, I'm just going to list this with bracket notation. So between -4 and 1, and between 3/2 and infinity. If maybe you're noticing patterns between the first two examples, it's rotating back and forth between positive and negatives. And that's what's going to happen at each solution, at each x-intercept or 0. It's not forever and always the case, though. So these are all single roots, which means they just pass through. If we have any double roots or triple roots or anything like that, it's not necessary, like we know it's going to come to the x-axis and could potentially turn back up. So there are cases where you could end up with negative beside a negative or positive beside a positive, but I would say over 75% of the time they should rotate back and forth between positive and negative. Example 2a, we're still just solving, just a little bit different. Step number 1, we should bring that x over here. So bring that over, becomes negative x. So this is going to be x to the 4 minus 8x is greater than or equal to 0. And I got to factor that. First thing you should do in your factoring toolbox, common factor, which is x cubed minus 8. X cubed minus 8, how do I factor that? Well, that's a difference of cubes, which we learned how to do last unit. So you might need to refer back to that, but if you remember the pattern, the cube root of x cubed is x, the cube root of 8 is 2, x minus 2, and then x squared plus 2x plus 4, greater than or equal to 0. Now, if you're thinking x squared plus 2x plus 4 factors further, it didn't for any of our cubics, it's not going to here. State your zeros, there's actually only 2. X equals 0 and 2. Make your modified kind of x-axis and put 0 and 2. We'll put some little boundaries on there. And we're going to test some values. Pick a number less than 0, -1. Now we have 3 factors, so you should have 3 things here. Negative, negative, positive, which that is a overall positive. And we want something that is greater than or equal to, right? So this is, in other words, something that is positive. So that is a solution. Pick something between 0 and 2, let's say 1. Put 1 into all 3 factors. You should get positive, negative, positive. That makes a negative, not a solution. And then pick a number bigger than 2. Let's say 3. When you put 3 in, you should get positive, positive, positive. Overall result, positive. That is a solution. Therefore, from negative infinity to 0, remember infinities always get circular brackets. Now since this is a greater than or equal to, this gets a square bracket. And from 2 to infinity, infinity gets a circular bracket, 2 gets a square bracket because it can also be equal to 0. Our final example, this looks like a big one, but we can do it. So the first thing you want to do, bring everything to one side. So that's going to become minus 2x squared minus 14x plus 16. Okay, x cubed And then minus 2x squared is negative 4x squared. And then 5x minus 14x is going to give us negative 9x. And then 20 plus 16 gives us 36. And this is greater than or equal to 0. You could use factor theorem on this. That is perfectly legit. So if that's the case, you can do it. However, I am going to point you to this actually does work a little bit nicer, or at least less steps, for factoring by grouping. So, and it's okay if you never recognize this. This is just another way to look at this. And if factor theorem's your comfort level, your default, by all means. But we're going to common factor in groups of 2. So what could you common factor out of those first two terms? X squared, which would leave you with x minus 4. What could I common factor out of the next two? Negative 9x minus 4. If you factored correctly, what's in brackets should be the same, which it is. So basically, we're common factoring again, which is x minus 4, and that leaves us with x squared minus 9. And x squared minus 9 is a difference of squares. X plus 3, x minus 3. And if you did factor theorem, you would have arrived at the exact same solution. So now we're ready to state our zeros. X equals 4, negative 3, and positive 3. Make our modified x-axis number line. Negative 3, 3, and 4. Put some little boundaries in. Keep things organized. Again, you are just testing values. So pick a number less than negative 3. Let's say negative 4. If we do that, we get negative, negative, negative. Multiply all those. That is negative as our end result. And we want greater than or equal to. So we only want positive values. So not a solution. Between negative 3 and 3, the easiest one would be 0. Negative, positive, negative. Which overall is a positive. That is a solution. Pick a number between 3 and 4. Let's say, I don't know, 3.5. That's going to be negative, positive, and positive. Negative, positive, positive makes a negative, not a solution. And then pick a number bigger than 4. Let's say 5. That's going to be positive, positive, positive. Overall, that's a positive. That is a solution. Therefore, our solution sets, negative 3 to 3, square brackets, because it has an equal to underneath the greater than, and 4 to infinity. Infinity never gets a square bracket, and 4 since it's greater than or equal to. Hopefully that's okay, and hopefully by the 4th time we've done it, it makes more sense what we are doing. Again, you should stick to this work for your test. There is some C work. Again, please make sure you're checking your C work on D2L, just because I keep taking questions away based off stuff I've taken out for the quadmester. And before moving on to the next video lesson, just a couple quick things. There's 5 lessons in this little mini unit. I have 2 assigned for Wednesday afternoon after your test, 3 assigned for Thursday, and then nothing assigned for Friday. You are more than welcome to deviate from that timeline if you want. So you could technically do 2 on Wednesday, you could do 2 on Thursday, 1 Friday morning, and then write your test. I'm going to have your test open. I think I'm going to have it open from something like 11:15 until 12:30. So you would have up until 11:15 if you need to do that final lesson to get that out of the way, or you could just use the morning to review. And if you're prepared, you could start your test at 11:15 and get an early start on the weekend. If you're not prepared, you could start after lunch at 12:30, and then you would have until 2:45 to complete your test. So again, 5 lessons. You don't have to stick to the timeline. If you need to speed it up or you want to throw one lesson into Friday morning, you can. My recommendation would be if you can kind of do that, like try to squeeze the 3 in on Thursday, and then that way you have all of Friday morning to maybe do some review questions, ask me questions for your test. That's it. Thanks for listening, and may the 4th be with you, which is when I recorded this.